Hello everybody, today we are going to be talking about the sun's energy and how it affects the earth. So you will notice we have a beautiful picture of our smiling sun out there, but we do not see the earth, so we're going to create an earth. So we're going to draw in our earth here. There's our beautiful earth. One thing to keep in mind is these are not to scale, and that's not a good circle either, but that's okay. Now, one thing to remember about our Earth is that it is always spinning. It is always spinning on its axis, and it is always revolving around the sun. So its axis is that point where the sun is spinning. So if we put in two lines right here, that's the Earth's axis. Sometimes people think that this is what the Earth is doing. We're spinning around like that, right? However, and that would put the equator like that. That's our equator. However, this is not how the Earth is actually spinning compared to our sun. So we're going to get rid of that axis, which is now gone, and our equator, and we're going to change it just a little bit. Oh, we also erase some of our Earth. So now we've got our Earth here, and instead of its axis being completely perpendicular to the sun, it's at a little bit of a tilt. So now we're going to put our axis right here, and we're spinning this way. Oh, that was a bad arrow. We're spinning this way, and our equator is now right there. Now this can have a major effect on our planet, because the sun's rays are coming to our planet, and that's how we get energy at the surface of the Earth. So if we see this now, we have sunlight that comes to the Earth at different angles. So now we've got an angle here, and we've got an angle here, and we've got an angle here. And depending on the angle that the sunlight strikes our Earth can determine how much energy the Earth is getting. So we're going to be looking at areas of direct light and areas of indirect light. So this is where I'm going to have you take a moment and discuss with a neighbor the places where you think in this picture are receiving direct light and the places that are receiving indirect light. Alright, thank you for discussing with your neighbor. Now that we've gone through where we have direct light and where we have indirect light, we are going to fast forward our Earth as it revolves around the sun by 6 months. So now we're going to take our sun, or our Earth, and it's going to go around the sun, and suddenly the Earth ends up over here. So now we have the Earth over here. There's our beautiful Earth again. One thing that doesn't change is the Earth's axis. So now we have the Earth's axis still in that direction. It's still spinning this way. And one thing that we will notice as that happened, we have changed the hemisphere in which that direct light is occurring. And so we've got these different angles now. So what I'm going to have you do is I'm going to give you and your partner a flashlight and some graph paper. And what I want you to determine, as soon as I pull up a new page, what I want you to determine is what angle of light will have, or what angle your flashlight will have the most concentrated rays. So if we move our sun aside for a minute and we go to a graph paper, I'm going to give you a flashlight, and you're going to hold it at 3 different angles on your paper. So here's our flashlight. I know it doesn't look like one, but it is. So you're going to hold it at 90-degree angles, then you're going to hold it at 60 degrees, and then you're going to hold it at 30 degrees. That's not a very good picture. And you're going to get light coming at these different angles. You'll be more exact with a compass on yours. and get the actual angles. And you're going to generate a hypothesis and then test it for which angle of light, or which angle you hold this flashlight will create the most concentrated stream of light.